Yeah, great to be here. Thanks for the invite from Ben and also Puffer and also Redius. And I believe for the entire day, right, all of you have been listening to all the talks from all these basic sequencing and all different debates around these sequencers. Either it's a single sequencer or it's a decentralized sequencing. And yeah, today I will just show a bunch of these efforts and also research for the past almost 2 years. So we've been done, especially with our partners around this ZKT and also a bunch of these new stuff we are going to provide either right now or basically for the next few months. You can see from this slide, right? So it's basically I'm going to show three of these stuff we've been working on. Because most of us here are geeks or these technical people, right? So I just show these kind of programming language to show you that first we go through something about this base rollup, and then we also discuss about the restate rollup, and then it's basically something we just announced last Sunday and try to bring all the rollups from state 0 to state 2. Not really working. So a little bit on the background. I think today we see a lot about this base rollup. Later I will also show the structure about it. But since we are talking about these restate rollups, so roughly, as you know, right, for most of the rollups right now, we have either OP stack, Arbitrum, or even all the ZK rollups. We have this single sequencer. That's why we need some extra sort of frameworks or extra features on top of them to decentralize sequencing or different components of the rollups. On our side, we've been providing a lot of the rollup services for a lot of clients who are working on this social gaming, deeping AI, and we figure out like ways like probably we can really leverage like some existing platforms. For example, Eigen, this restaking platform, to have this decentralization for different components. So that's why since last year, we together with Shram, founder of EigenLayer, to propose this new idea called Restaked Rollup. It consists of multiple AVSs for decentralized sequencing, verification, and also faster finality. That's a squad, vital, and also mark. And as you can see, right, we basically create a decentralized network with a lot of operators by leveraging this shared security of ETH from this the Eigen platform. And beyond that, you can just treat it as a pure as a network, and we can sort of do all these decentralized sequencing verification and also faster finality for different rollups. Beyond that, as you can see for the basic rollup, right? For the restate rollup, the idea that we have the decentralized network to secure some components for the rollup, mostly for the verification, also faster finality. We don't want to change the existing stacks of OP stack, Arbitrum, Orbit, and some other ZK rollups. But as Sam just mentioned, right, we also have this base sequencing based rollup. The idea that if we want to decentralize this sequencer, right, the best way that we need to leverage the biggest or most decentralized network, that's Ethereum. So then the idea, as you can see, right, we leverage the validators or different roles on Ethereum to basically do the sequencing for us. So in that case, it's not just about decentralization of the sequencer, but at the same time, we also give back the fees to the Ethereum. But however, as you can see, right, there's a bunch of drawbacks of this approach. So basically, since we leverage Ethereum to do the sequencing, there's some finality time for it, right? Typically 12 or 13 minutes. And so in that case, later we will briefly mention what are the ways to address it. It's basically, we need to leverage this pre-confirmation mechanism. As I just mentioned, right, either for based rollup or for restate rollup, the main purpose for it is really to provide the decentralization for the existing rollup stack. And the first thing we always mention is about how we decentralize the sequencing. For Restaked rollup, right? As I just mentioned, right? We don't really want to change the stack too much. So in that case, as you can see, right, we typically leverage some external networks and to achieve some of the goals we want to have here. And as I mentioned, right, for Squat, we leverage like sort of the operators on this eigen platform, and they form a network to do this extra sequencing work, and after that they will return back to the existing sequencer. Of course, in multiple ways, we can have this non-consistent way, basically leverage these eigens BLS and to aggregate these signatures, or we can also leverage some consensus-based basic solutions like this Espresso or this Radius. And then on top of that, for the based rollup, we all know that for the sequencing part, as Sam mentioned, right, he already did a very good presentation on that. Of course, as we mentioned, right, we need this L1 to do sequencing, and basically since there's sort of some delays for the finality part, typically we really need to figure out ways to address these problems. And after that, as you can see, right, to further reduce this confirmation time on the L2 sequencer side, if we really want to achieve it, we definitely have some pre-confirmation protocol for it. So in that case, right, for decentralized sequencing, especially for based rollup, on top of that, if we really want to provide a very good user experience, pre-confirmation protocol becomes the must for it. And then on the Restaked rollup side, right, do we have something similar? Of course, because for Restaked rollup, most of the AVS or components are not like sort of big changes for the existing rollup stack. So you can choose what are the AVSs you want. For example, you can still have the single sequencer, and in that case, you can really have this software confirmation in like sort of 2 seconds or even sub-second. And beyond that, as I just mentioned, right, if we want to have this fast finality layer instead of the pre-confirmation layer, we can also leverage these restaking platforms operators to form a network. Here we call it a mark network to do the extra verifications for the transaction blocks from this single sequencer. So in that case, right, it's a little bit different from this based rollup, which we have the sequencing done by Ethereum, but we need pre-confirmation to really shorten the latency for the user experience. But here, even we have the single sequencer is right decentralized, but we can have a separate network to do this extra verification to make sure, like for the users, they can quickly get to the finality on the on this mark network. Of course, as I mentioned, right, also Sam mentioned, there's a bunch of ways to do this pre-confirmation for the based rollup. One way is to have this sort of pre-confirmation gateway. Of course, we can put it into TE to handle all these based rollups. So in that case, as mentioned, right, it's a little bit centralized. So that's another part. Like we can also incorporate the restaking platform into it. We can have a rightly decentralized network, basically consisting of a bunch of operators for this pre-confirmation protocol, right? We can also have the commitments. If something wrong, we can slash them with that sort of the stakes, like staked on this restaking platform. Of course, people asking, right, why we are talking about this restaking over and over again. I think like we can definitely achieve the same goal without this restaking platform. It's just like it's a little bit tough, I would say. You need to onboard a bunch of these operators or validators yourself. It's similar to launching an L1 protocol. And beyond that, we also need to attract enough TVL to secure the protocol. But if we are leveraging the existing restaking protocol like Eigen, right, we can easily achieve like probably over 1 billion TVL to secure a network, and over 300 sort of operators already stand by. We can onboard them. So for me, based on the experience, right, we feel like it's definitely we can start a network without any involvement of this restaking platform. But if we can leverage the restaking platform, it's a very good way to bootstrap this decentralized network. So that's a part I answer it, right? So for based rollup, we definitely need this pre-confirmation protocol or this gateway for a much better user experience. If they send transaction, definitely want some confirmation within 2 seconds or sub-second. So that's a way to have this gateway or like sort of the network. But as mentioned, right, either we can leverage the existing Restaked rollup, restaking sort of mechanism to quickly launch a platform, or we can basically work on our own like sort of operator site to power or to bootstrap this network. And beyond that, as Sam mentioned, right, there's another feature or another metrics we need to measure for both Restaked rollup and also this based rollup, and that's composability. So far there are tons of like sort of rollups in the space. If you look at L2B, probably we already have 50 or even over 50, but in general, I think we already have over a few hundred like sort of rollups in the space. So in that case, if we really want to do some cross-chain functions or features, for example, we do swap from one rollup A for some tokens, and we want to get the tokens on rollup B, right? It would be great like we can have some shared sequencer or some similar functionalities to make sure the transaction from one rollup can achieve like sort of the result from another rollup with proper composability. And there's some sort of conception. Basically, like people feel like this atomic composability means atomic inclusion. For example, if a transaction on 2 rollups already accepted at the same time, then it's basically sort of the composability. But actually, it's not 100% true, because we also need to consider this execution. For example, if I do a swap on rollup A and try to get some token from rollup B, right, the transaction have to be successful. Otherwise it's sort of like I put the money on the rollup A, but I didn't get the sort of corresponding tokens on rollup B. That's not really the composability. So in that case, right, there are multiple ways. For example, for the base rollup, one of the biggest benefits we can get is about this interop across all different base rollup, right? Because all the transactions ordered and basically recorded like on Ethereum. So in that case, once these transactions are confirmed on different rollups, probably by the pre-confirmation protocol, and after that we can really get a quick like sort of confirmation for this kind of across rollup transactions and also the assets across different rollups. So in that case, right, we can really have this atomic basically composability across different rollups for this based like sort of rollup. And then for the Restaked rollup, we also have something similar. It's still back to the MARC protocol, and for MARC, it definitely a separate network. It can operate and do the verification across different rollups. So it's the same thing. It's just like after this sort of like sequencer producing the blocks and also transactions, but it achieve almost the same goal. And since the MARC can process all the sort of the verification of the transaction blocks across the different rollups, probably A, B, C, D, E, right? So in that case, the good thing is like the user developers from DeFi bridges and also exchanges, right? They can just query this MARC network for the transaction confirmed on different rollups. So in that case, you can see, right, we can really achieve this fast sort of finality and at the same time also interoperability across different rollups. As I mentioned, right, it's the same thing. We can build using it using like existing restaking platform like Eigen to quickly bootstrap this network with all the operators. Or if we don't want, we can also leverage our own tokens to basically provide enough security and also TVL for this network. It's just like with Eigen or this restaking platform, it's much easier and probably much faster to bootstrap this network. And as I mentioned, right, as you can see, for based rollup, it mainly focusing on this decentralized sequencing and try to get back all the rewards back to the Ethereum. And so in that case, we can have the decentralization. At the same time, we can see that the Ethereum gets most of the sequencing fees from the L2s. However, for Restaked Rollup, typically, especially the ones we launched for the past 1 year, we launched a few like 5 different Restaked Rollups like Cyber, Exterior, Dodo, and this GM. For most of them, I would say the main focus actually is on this past sequencing. It's basically post sequencing, this kind of verification. We still embrace the single sequencer because we don't want to change like sort of the vanilla rollup stacks like OP stack or Arbitrum Orbit stack. However, we do extra verifications after the sequencing. So in that case, as you can see, right, it's agnostic to all the rollup stacks, but at the same time, we can also achieve almost the same goals for interoperability and also for faster finality. And then the last part I would say, since we have all the different research and all the different sort of new improvements on ZK coprocessors and different proving system, right? And last Sunday we announced a very big sort of thing about the sort of this stage 2 multi-prover system. And roughly, here I will quickly go through what's the difference between stage 0, stage 1, stage 2 rollups. For stage 0, as you can see, right, you just need to call yourself as a rollup with proper deposit with raw functions. You don't need like sort of a fraud proof or validity proof system. So that's sort of like the stage for most of the OP stack rollups like for the past 2 years. But recently they enabled the fraud proof and basically you can see the later I can show you OP is become the stage 1. And then for stage 1, for the technical requirements, really about you need minimum 1 proof system. It's either fraud proof or validity, this kind of ZK proof. But of course, there are some non-technical requirements, like for example, you need to have a security console. And this security console need to be the multi-sig, and for any this kind of major upgrades or bug fixing, there's a delay. You can't directly upgrade it. There's a delay for the community to really know that, okay, there's a major upgrade. And then for stage 2, the technical requirement becomes like more strict. Basically, it requires minimum 2 different proof systems. And so in that case, right, 1 proof is not enough. We need multiple proof systems, like this different ZK proof system or the like sort of TE proof systems. And then for the requirement of security console is also a little bit different. We limit the power of security console, and basically you can only upgrade unless there's some urgent bug fixing or like sort of these 2 different or multiple different proof systems, they don't agree with each other. If you look at all the existing rollup like sort of mainnets, right? Most of them, I would say, they're still stage 0. And Arbitrum, the good thing, like they really had this fraud proof almost since day 1. OP just enabled this fraud proof like a few weeks ago. However, as you know, right, we as a researcher, we always want the best thing. We want the sort of the best security guarantee, the best safety guarantee for all the rollups. So in that case, we want to move all the existing or the future rollups directly from stage 0 to stage 2. So that's why since last Sunday, we introduced sort of the Restaked Rollup second feature called Vital. We want to bring all the rollups directly to stage 2 with multi-proving systems. So one thing is, as you know, right, so for all the existing like sort of optimistic rollups, especially powered by OP Stack or Arbitrum Orbit, we have this best section for proof systems. And also for existing rollup systems, we also have this ZK or validity proof systems. And beyond that, I know this automata already provide this TE prover for linear and also scroll. And so right now, I just feel like in crypto space, we really have all these different proof systems ready. So we can really bundle them together and provide for our existing clients or the future partners to use them. And the cool thing is like, as you know, right? At AltLayer, we are not just a service provider. We are doing a lot of research for the past few years, and we collaborated with Research Zero for the last year, and came out with this ZK fraud-proof system. So it's like a combination of the security of ZK proof and also the less cost of fraud proofs. The idea is quite straightforward. We all know that for fraud-proof or fault-proof systems, right? There's a bisection protocol. If something wrong, there's a 7-day time period for this challenger and also batcher to debate on who is correct and who is wrong. But this one is typically very lengthy, and it takes around 7 days. And we basically changed this bisection protocol directly to generate this ZK proof for the past few blocks and few transactions. So in that case, if any dispute for the past few transactions and blocks, the challenger can directly generate the ZK proof and post on the L1, the Ethereum. Ethereum can do the verification for this proof. As you can see, right, it's a really good combination, or it's a middle ground to we really have like sort of ZK proofs, correctness and also safety, but at the same time also enjoy the less cost and affordable this fault-proof system. Of course, there's something, if you look at these extra things, right, as I mentioned, the multi-proving systems, right now we also have the TE prover. The entire process is quite similar to actually ZK proof. It's just like we replace the ZK proof generation with this TE attestation report. And as you can see, right, regularly you need to have this attestation report generated, and at the same time, we need to have the verification on chain, either on Ethereum or on different L2s. But as I mentioned, right, on our side, we really work closely with our partners for these multi-proof systems. For example, for ZK part, for the fraud-proof part, we work with OP and Arbitrum. So by default, they already have this proof system. And also for the ZK fraud-proof system part, we work with Research Zero, and we already have that kind of. They are going to announce something very soon. And beyond that, for the typical ZK, like sort of validity proof system, we have OP Succinct, and basically they can generate the validity proof regularly to replace the fault proof system, and then further shorten this withdrawal period. And also we work with Automata on this TE prover side. So in that case, as you can see, right, we already have a big bundle of different proof systems now. Not just for our existing clients and also for new clients, we can just offer this bundle of different proving system for them. So quickly with Vital, we can bring all these rollups from stage 0, stage 1 directly to stage 2. A quick summary of this presentation. I would say like I help you, all of you, go through like basic rollup and also restaked rollup, as you know, right? Basic rollup focus on this decentralized sequencing. Restaked rollup really focusing on this verification and faster finality part. And beyond that, we also having this Vital protocol, try to bring all these existing and future rollups from stage 0 to stage 2. And for us, like we really focus on the research and try to really bring the best decentralization and also security for all the rollup platforms and applications and projects. If you would like to work with us, just scan the code, and yeah, hope you enjoy the talk. Thank you.
Do we have any questions for YQ? We do have one.
Thank you for the presentation. Can you elaborate more on how you can like reduce this challenge period? When you mentioned that we can reduce the challenge period when we use like this ZK fraud proof.
Oh, the thing is like you know, right? During this bisection protocol for this fraud proof, why is 7 days? Because we want to ensure either the challenger and the batcher has enough time to upload like sort of their this kind of disputes on chain. So in that case, here we directly replace the entire bisection protocol with the ZK proof. So we just need this challenger to submit once successfully of the entire ZK proof for the past few transactions and blocks. So in that case, you can see, right, for the bisection protocol, probably you need challenger and also batcher to submit probably like 20 or 30 different transactions for the disputes, and to figure out like which transaction or which instruction is wrong. But here you can just submit like one proof in one time, and then like sort of the L1, the Ethereum can do the verification. So you can dramatically save a lot of time. And probably from 7 days, you can just save it into like a few hours or a few minutes. It really depends on like how quickly you can generate the ZK proof for this challenge. Yeah.
It's like, isn't that the challenge period meant to be like to prevent the sequencer from like DDoSing
yes,
the network?
It's
so
DDoS. That's why, as I mentioned, right, previously, why it's very long enough, because you need to finish this bisection protocol for over 20 or even more transactions to be submitted to Ethereum. But right now, you just need to successfully submit one. It's enough. So that's why you can dramatically shorten this period from 7 days to a few hours or a few minutes. Yeah.
But it's like the sequencer still can like censor the network in like for 5 hours, right? So
that's why like unless, because here, right, the like you can do this way. For example, 7 days is for 20 transactions to be submitted to the L1, like for a long period of time, right? But right now you can proportionally you can use 7 days divided by 20. You get my point, right? Then just you shorten to a few hours. That's the simplest math. But at the same time, for most of the time, people don't really DOS this stuff, you know. And then once you generate ZK proof, right now we are working with some proof systems like Range, and they can generate the proof probably within a few minutes. Or if you really have a lot of budget, can generate a proof within a few seconds. So in that case, the withdrawal time can just be within a few minutes instead of 7 days. Yeah. We can discuss this offline if you want, because because the sequencer is not just a sequencer. Sequencer has minimum 5 different components. And typical we say this bisection protocol, right? It's not between the challenger and the sequencer. It's between, there has a typical role called batcher, or someone will submit the state root hash to the L1. So it's like sort of different roles. It's just like when we talk about all the rollup stuff, right? We just simplify everything. But if you look at the implementation on code base, it's definitely not that simple. Yeah.